Welcome to Study Loop.
In part A, we're asked, is stearic acid more soluble in water or carbon tetrachloride? Remember, for solubility, we want to keep in mind that like dissolves like. If you have a nonpolar solute, it's going to dissolve in a nonpolar solvent. If you have a polar solute, it's going to dissolve in a polar solvent. So water, as we should know, is polar. It has a dipole moment. Carbon tetrachloride is nonpolar, even though the carbon chloride bond is polar. The fact that it's symmetrical makes it a non-polar molecule. Okay, so the question is stearic acid polar, therefore soluble in water, or is it non-polar, therefore soluble in carbon tetrachloride? Now, I will admit that stearic acid has this polar group, but it's got such a long chain of carbon-hydrogen bonds that are all nonpolar. And so, since the bulk of this molecule is nonpolar, it is going to dissolve in the nonpolar solvents. So, stearic acid we expect to be more soluble in carbon tetrachloride because it is primarily a nonpolar molecule. Part B says, which is more soluble in water, cyclohexane or dioxane? Recall that water is polar again. So if water is polar, we're looking to dissolve it we're looking to find the solute that's also polar. Cyclohexane has all of these carbon hydrogen bonds that are nonpolar, while dioxane, while it looks very similar in makeup, it does have these oxygens that add polarity to it. So I would say that dioxane is polar while cyclohexane is nonpolar, which means that we expect dioxane to be more soluble in water.